Hello children, today we will discuss a small topic of redox reaction, that is law of equivalence. What does it state? That one equivalent of an element will combine with one equivalent of other, and in a chemical reaction the equivalent and the milli equivalent of reactants react in equal amount to give the same number of equivalent or milli equivalent of the product separately. मीनिंग ये है कि अगर तुम्हारा ये जनरल इक्वेशन है ए रिएक्ट्स विद बी गिविंग यू एम प्लस एन, ठीक है, तो मिली इक्विवेलेंट ऑफ ए विल ऑलवेज बी इक्वल टू द मिली इक्विवेलेंट ऑफ बी विच इज रिएक्टिंग, and it would give a product where you have milli equivalent of m equal to milli equivalent of n. Okay, so all these will come out to be equal. So in a compound like mx plus ny, milli equivalent of mx ny will be equivalent to milli equivalent of m equal to milli equivalent of n. Now equivalent, I suppose you remember what is equivalent. When we had discussed about normality was what? Normality was equal to the number of equivalents or the number of milli equivalents divided by the volume. Okay, so when I say milli equivalent, it is actually, see, normality will be equal to number of equivalent भी हो सकता है, or it can be number of milli equivalent. Okay, milli equivalent divided by volume. So when I take N1 V1 or N into V, when I take, that will be equal to number of milli equivalent if your volume is in ml. If your volume is in liters, then N into V will be equal to number of equivalents. That is how it is. Okay, so this is what it means कि जितना हम मिली इक्विवेलेंट A का लेते हैं in the first reaction, it will react with equal amount of milli equivalent of B, and it will give equal amount of milli equivalent of M and milli equivalent of N. That is what we call as the law of equivalence. So for an acid base reaction or a redox reaction, we can see that N1V1, see, N1V1, N into V. N1V1 will always be equal to N2V2. Why? Because N1V1, it is the number of milli equivalent of A, that is the reactant, and that will be equal to the number of milli equivalent of the other reactant. Also it will be equivalent to the product and any number of product which is forming. So always N1V1 will be equal to N2V2. Or we can write M1V1 is equal to M2V2, but it may not be true in all the cases. Say for example, when NaOH is reacting with H2SO4, your M1V1 will not be equal to M2V2, because there you will find NaOH dissociates into Na plus and OH minus, while H2SO4 will dissociate into H plus and SO4 2 minus, where 2H plus will be released. Okay, so when I say NaOH and H2SO4 ka reaction, there you cannot take the M1V1 term, because there the milli equivalent of NaOH and milli equivalent of H2SO4 is not equal. That time we are not calling it as milli equivalent, because ये M है, M तो molarity के लिए होता है, and molarity में we will consider it as number of moles or number of millimoles. Okay, and that will be different for each one of them. That is H2SO4, it dissociates into 2H plus SO4 2 minus, while NaOH will dissociate into H plus OH minus and Na plus. So 2H plus ions are present and only one OH minus is present. So then how will the neutralization take place? So it won't take place with the molarity term, we cannot find out this, but with normality term we can find, because normality considers equivalence, which is the weight of the substance upon the equivalent weight, and equivalent weight of H2SO4 will be half of the suppose 98 है, NaH H2SO4 का molecular mass is 98, 98 और n factor उसका 2 है, that means 2 displaceable hydrogens. So 2 divide by 2, that will give you 49, and 49 grams of H2SO4 will only have half the amount of H plus ions. So that half amount of H plus ions will neutralize the OH minus. हाँ, इसका 2H plus का half क्या होता है? Only H plus. So equal amount of H plus and equal amount of OH minus will be present. Are you understanding the meaning of this equivalence? इक्विवेलेंस में हम लोग हमेशा मॉलिक्यूलर मास को डिवाइड कर देते हैं n फैक्टर से. तो सो इन दैट केस द रिएक्टेंट्स विल बी हैविंग सेम नंबर ऑफ इक्विवेलेंट्स. ओके, सो दैट इज हाउ यू हैव टू अंडरस्टैंड इट. सो इट मे और मे नॉट बी ट्रू. It may be true for acid base reactions like NaOH and HCl, but it may not be true for acids like H2SO4 and base like NaOH. वहाँ पे दोनों का n फैक्टर डिफरेंट है. n फैक्टर अगर डिफरेंट है तो मतलब यू कैन नॉट अप्लाई द लॉ ऑफ इक्विवेलेंस. दैट टाइम m इक्विवेलेंट ऑफ A डज नॉट बिकम इक्वल टू m इक्विवेलेंट ऑफ B. m इक्विवेलेंट मतलब मिली इक्विवेलेंट. ओके, बट यू कैन हैव दिस part correct, that is M1 V1 N1, where N1 is the n factor of any substance, whether it is an acid, base or a salt or a oxidizing agent or a reducing agent, सबका n factor it will be there, no? That n factor when you multiply it with molarity, actually you will get normality, because normality और molarity का relation क्या है? That is only the relation, isn't it? Normality is equal to molarity into n factor, Followed all of you? Okay. Now similarly this is M1 into N1 will give you the N1 only, that is normality. That is N1 V1 will be equal to N2 V2. यहाँ पे M2 into N2 will give you N2 value, normality value, okay, into V2. So it is always true, and n in this case is your n factor. ठीक है? So let us do one question. Calculate the normality of solution containing 15.8 gram of KMnO4 in 50 ml acidic solution. यहाँ पे normality ही पूछा है. Normality का formula is what? Normality is equal to weight of solute upon equivalent weight of solute into 1000 upon volume in terms of ml. तो हमारे पास weight है equivalent weight of KMnO4. You know molar mass of KMnO4. If you calculate molar mass of KMnO4 will be equal to 158. Calculate करके देखना. K 39, 55 plus 64. 39 plus 55 plus 64. It will give you 158. Molar mass of KMnO4 is 158. और equivalent weight हमेशा क्या होता है? Molar mass of KMnO4 divided by n factor. तो n factor of KMnO4, n factor मतलब कितना इलेक्ट्रॉन्स रिलीज होता है. हमने इक्विवेलेंट वेट ऑफ KMnO4 के बारे में पढ़ा था in our previous video. So that will be 5 electron. So therefore equivalent weight of the solute, that is KMnO4, will be 158 divided by 5. So you have weight of the solute as 15.8. You have equivalent weight, that is 158 divided by 5. So I write my 5 here, into 1000 upon 50. इस तरह से मिलेगा. ओके, सो 5 1s are 5 10s are cancel out, and again if you bring this 150 point हटा के नीचे 10 लगा दिया, so this and this will cancel out. So 158 1s are, which is equal to 10. So normality of the KMnO4 will be equal to 10 normal. Okay, it will be 10 normal. Followed? Okay. Now let me do this question. Find the, I am rubbing out this, okay. Find the number of moles of KMnO4 needed to oxidize 1 mole of Cu2S in acidic medium. The given equation is here. So, I am rubbing out here, okay, you can copy, pause the video and copy it down, okay. It is given, find the number of moles of KMnO4 needed to oxidize 1 mole of Cu2S in acidic medium. So, let us write the equation first. KMnO4 plus Cu2S gives you Mn plus 2 plus Cu plus 2 plus SO2. Okay. Now, you have to identify which is undergoing oxidation, which is undergoing reduction, because हमें number of moles पूछा है and number of moles into valency factor will be equal to number of moles into valency factor. Milli equivalent of KMnO4 will be equal to milli equivalent of the Cu2S. Okay, ये law of equivalence हम apply कर सकते हैं. So let us see how we can apply. ये plus 7 है, ये plus 2 है, मतलब here your n value is 5. Reduction 5 का हो रहा है, okay. जबकि Cu going into Cu plus 2, यहाँ पे Cu is having a plus 1 oxidation state, sulfur is having minus 2 oxidation state. Here Cu goes to plus 2 state, here Cus goes to plus 4 state and here O is minus 2. तो ऑक्सीडेशन प्लस 1 से प्लस 2, मतलब ये जो Cu का है n is equal to 1. Now what is it for sulfur? Here you can see it is going from minus 2 to plus 4. That is minus 2, minus 1, 0, 1, 2, 3, 4. 7 का difference है. So here n will be equal to 7. So total n will be equal to, ये n1 ले लेने का और ये n2 ले लेने का. It will be equal to what? n1 plus n2, which is equal to 8. Okay. So 8 electrons का displacement है यहाँ पे. So we can say that number of moles of KMnO4 into n factor of KMnO4 will be equal to number of moles of Cu2S into n factor of Cu2S, okay, of Cu2S, ऐसा होगा, ठीक है. तो what is number of moles of KMnO4 वो हमें find out करना है ना. Find the number of moles of KMnO4 needed to oxidize 1 mole of, so that is number of moles into n factor of KMnO4. हमें number of electrons वही हुआ उसका n factor, number of electrons required या number of electrons gained by KMnO4. So 5 electron will be equal to number of moles of Cu2S. It is given as 1 into what is the n factor of Cu2S given? It is total 8. n1 plus n2, it becomes equal to 8. So you have this. So what is the number of moles? It will be number of moles of KMnO4. It is equal to 8 by 5, isn't it? So it will be 5 ones are 5, 30, that is 1.6 moles. Followed all of you. So you should get it as 5 by 6, 8 by 5, which is 1.6 moles. I hope this is clear. Okay. So this is how you can apply the law of equivalence. I will give you few questions for solving today. You can do it. Okay. So we have done a very small topic of law of equivalence. ठीक है.